Students, this is Unit 2, Segments, Lines, and Angles. This is Lesson 2.4, the preview video and notes. Angle measures and pairs. You should have your new set of preview videos. Taking a look here, we have the calendar for the next 2 months. Use this page if you choose to turn any late work or absentee work. How to use this packet, couple recommendations. One, follow the instructions given in the video. When you're told to pause and work on your own, pause and work on your own. Then check your work. Don't cheat by just waiting for the video to go on and copy. You should always both watch and listen and follow through. Don't just copy the video down. When you're finished, this will increase your comprehension significantly. Just close your booklet and in 2 minutes verbally review the content of your lesson to yourself. Talk to yourself through what you learned. Remember to get your notes signed by a parent or guardian or a teacher affirming your efforts. Students, keep in mind that you are always invited to complete these preview lessons in person if you choose to. Stop by for tutoring during lunch, after school, or during optional second if you have it. Just complete your notes with the teacher prior to the due date. How I grade the notes are here. Let's start with today's lesson. So remember, when you're done with today's lesson, make sure you put the location that you watched the video, the date and time, as well as your parent sign-off. Ready? Here's your first opportunity. I'm going to read this, and then you're going to hit pause and attempt to do this on your own. So put your finger right there and read with me. You're going to draw a segment with 3 collinear points, CAT, where point A is the midpoint of CT. Distance CA is 3x plus 10. Distance AT is 5x minus 14. Find everything possible. Pause, do this on your own, then restart the video. Okay, welcome back. Let's see how you did. So we have here 3 collinear points, CAT, where point A is the midpoint. So you should have drawn something that looks like so. It's a midpoint, so hatch marks. Cross that out. You've accounted for that. The distance of C to A is going to be 3x plus 10. A to T is 5x minus 14. Find everything possible. Let's see what we can do here. Well, we know that this is the middle. So let's do a things first equation. We know that the distance from C to A is equal to A to T. So then you circle, plug, chug. CA, pick it up, plug it in. Why did I physically circle that? That helps your eyeball from making simplistic mistakes. Circle, pick it up, 5x minus 14. Now you should have solved for x. So I'm going to minus 3x, minus 3x. I have 10 equals 2x minus 14. So I'm going to go plus 14, plus 14. 2x equals 24. Divide by 2, and we have x equals 12. Woohoo! You think you're done? Not on your life. So you always want to take the opportunity when it says find everything possible, see if you can't plug in x somewhere, which we can, right here and right here. So I'm going to plug in x. CA is 3 times 12 plus 10. That's going to be 36 plus 10, so it's 46. So this is 46 up here. AT is 5 times 12 minus 14. That's going to be 60 minus 14, which is also 46. But wait, there's more. You could also do C to T. From here all the way over, we can just do 46 plus 46, and we get 92. Make sure you always solve for everything possible. Okay, that's our review. On to today's new material. This is lesson 2.4, angle measures and angle pairs. Read these words aloud with me. Obtuse and acute, linear pair, adjacent, complementary, supplementary, vertical. By the time you're done with today's lesson, you should be familiar with these terms. Okay, an angle is just two rays joined at a common point, also known as a vertex. It's two rays joined at a common point, also known as a vertex. That would be the vertex right there. So we're going to try drawing an angle XYZ with Y as the vertex, and the actual measure is going to be 65 degrees. Now because I say Y is the vertex, Y is like the elbow of the angle. So I stick it right here. That's going to be point Y. And now we're going to draw 65 degrees. We can go to the right or the left, it doesn't matter. But I'm going to start by drawing a straight anchor line, or what I call an arm line. And I'm going to go up the protractor, 65 degrees. I'm going to draw that second ray. And it's going to be X, Y, Z. So there's X, Y, Z. I could have gone the other direction as well. It doesn't really matter as long as Y is in the middle. Now, it's very important, every time you draw an angle, get used to what's called trace and sweep. So when you have angle X, Y, Z, you should trace it. X, Y, Z, trace, and that's called sweeping. Now, there is a difference between this. If I do this angle X, Y, Z, notice that angle symbol. I'm talking about the physical angle itself, the thing of the angle. Versus if I do this, it's very subtle, be very careful. I write measure of the angle. That little M there means measure of the angle. XYZ. Measure of the angle. If you see that little M there, that means I don't want the actual angle, I want its degrees. So that little M there, I'd write measure of the angle is 65. That's measure. So watch out. If I put that M there, that means measure of the angle, and I'm looking for the degrees. If it doesn't have the M, it means we're talking about the physical angle itself. Let's do an example here. We're going to draw angle EFG with an interior ray of FV and an interior point of U and an exterior point of W, one step at a time. First we have angle EFG. Since F is in the middle, that means F must be the midpoint. No, excuse me, not the midpoint, the vertex. Now let's draw our two rays. EFG. So we've drawn an angle with EFG. Trace and sweep. There's our angle. We have an interior ray of F to V. Same letter, same point. So that F right there is the same F here. It's interior, which means it's inside. Warning, unless I say the word bisect, do not put it in the middle. You'll confuse yourself. So I'm going to offset it a bit. And it's F to point V. That's an interior ray. It's inside the angle. We also want an interior point U. That just means point U is anywhere in the mouth of the angle. It doesn't really matter where. And then we have an exterior point W. That means W is outside the angle. Interior, exterior. Think of it, interior is inside the mouth area of the angle, and exterior would be outside. Ready? This is where you want to stop the video, pause it, do this problem, and then restart. Okay, let's see how you did. So we have here, we're going to draw an angle CAT with an interior ray of AD. So here's CAT. A has to be in the middle, or vertex, so the A is your hinge. C and T are either one. It doesn't matter which one it is, as long as A is the vertex. And we have an interior ray AD, same letter, same point, so that is that point right there. I tell you it's interior, not a bisector, so do not put it in the middle. Offset it a bit. And it's A going to point D. Says, I want you to trace and sweep CAD. So you should have done this, C, A, and D. Then it says draw an interior ray inside of CAD. So inside of CAD, you wanted to draw another interior ray. Again, it doesn't say the middle, so don't put it right in the middle so you don't confuse yourself, and we're going to label that AE. Trace and sweep, CAD. All right, you should have something that looks like this. Let's go back, add a few more other items here. There are 4 types of angles you should be familiar with. There is a right angle. Make your little box. That box means exactly 90 degrees. If you're going to draw a right angle, you must have that box. So it's an angle which is equal to 90 degrees. An acute angle is less than 90. So it's less than a corner. An obtuse angle is bigger than 90. To remind myself that it's bigger, I usually say it with a deep voice. I call obtuse. And then you have what's called a straight angle. And a straight angle is just what it sounds like. It's basically a straight line, so we say it's 180 degrees. Let's see what we can do here. We have a problem. It says draw an acute angle RST with an interior ray SO. Let's draw just that. We have an acute angle RST with an interior ray of S to O. Notice S is the hinge. Says it's acute, so it has to be less than 90. We have an interior ray SO. It doesn't say it's in the middle, so we're going to offset it. Now it says that RSO, not Q, O, RSO is 3 times as large as OST. So let's trace and sweep. RSO is 3 times as big as OST. So this is 3 times bigger than that. We don't know either of them, so we're going to call this X, and that makes this 3X. We want to trace and sweep RST. So here's RST, trace and sweep. And we're told that that RST is 76 degrees. We're going to find everything possible. Now let's look at what we have here. We have here we have a little red angle, and if we were to add the blue angle, we'd end up with the larger angle, this one. Remember, we always talk about things before we talk about the algebra. Now, with that, let's circle, plug, chug. So the red is going to be 3x plus the blue is x equals our yellow, which was the whole thing, 76. Go ahead, start working your algebra. Let's collect like terms. Get your hands off the calculator. Single and double digit division you should try to do by hand. So 4 goes into 7 one time. Bring down the 4. That's 3 left over. There's 36. 4 goes into 36 9 times. So we have x equals 19. Wonderful! You're not done. This is not algebra class. You don't end with the variable. It says find everything possible. So what we just found was x, and x is this angle. So we just found that x was, 19 degrees. So now, to find the red, we're going to do 3 times 19. Again, get your hands off those calculators for a single digit multiplication. 3 times 9 is 27. Carry the 2. 3 times 1 is 5. Plus 2, that's going to be 52. Let's try that again. 3 times 9. It's getting late. Let's see. That's 7. Carry the 2. And that's 57. There we go. 57. Ready? You try this one on your own. Pause the video and return when you're done. Okay, students, let's see what we have here. It says to draw a right angle DOG. So hopefully you saw that word right. So we're going to start by drawing a right angle DOG. And it's right, so I put that little 90 there. And we have an interior ray of OT. It says it's interior, but it doesn't say it's in the middle, which would be the word bisect, so we do not draw it in the middle, so you don't confuse yourself. You should have had T here. And then we have DOT is 4x plus 5. TOG is 4x plus 13. Don't forget this last information. This whole thing is 90 degrees. There's no bisector there, so we're going to do this. But we can say that the blue angle plus the red angle equals 90 degrees. So you should have 4x plus 5 plus 4x plus 13 equals 90. From here, let's collect like terms. So I should have 8x plus 18 equals 90. Minus 18 both sides. I have 8x equals 72. Divide by 8. And of course x equals 9. Fabulous. You're not done. You should have plugged it in. So to get the blue, it's 4 times 9 plus 5. That's going to be 36 plus 5. That should equal 41. Since this is 90, to get this, I can simply do 90 minus 41. And you're going to get, for the red, should have gotten 49 degrees. And then this is already 90. Now you found everything. A couple more vocabulary words and we'll be done. Adjacent angles. Adjacent angles are angles which share a spine. So in this case, trace with me any two angles that share the same spine, or what's also called the common angle. So if I have this ray right here, these angle ACP and angle PCZ, we would call these adjacent because they share a common angle. They share a spine. They're back to back. They're touching. That's adjacent. A linear pair. A linear pair are angles which are automatically adjacent, so they share a spine, but they also make a line. Share a spine, make a line. Say that out loud. Share a spine, make a line. So there's several examples of linear pairs in this diagram. We're going to start by just finding a line. So trace this line F to P. Just trace it. Ready? Any two angles that are back to back, they share a spine, they make a line. That's a linear pair. So I'd like you to trace the angle F, C, Z. Trace the angle Z, CP. These two angles, F, C, Z, Z, C, P. These would be called a linear pair. They share a spine and they make a line. Vertical angles. Put a star by this. It's by far the most common. Vertical angles are two angles which are opposite of each other, created by two straight lines. Think of them as bow tie angles. I also call them cat whiskers. Notice I put hatch marks. These vertical angles, bow tie angles, cat whisker angles, whatever analogy you want to come up with, they're always going to be congruent. So any two straight lines. So this angle here, RCF, and the other angle PCZ, those are vertical. Now we have two angles. Complementary and supplementary. Complementary angles are two angles that add up to 90 degrees. They add up to 90 degrees. So any two angles that add up to 90. So in this case, let me tell you what is not a complementary angle. ACP is not complementary because it by itself equals 90. Complementary angles are two angles that add up to 90. So in this case, angle FCR, the blue angle, and RCA, the pink angle. These two angles together would be complementary. They add up to 90. This is how I remember complementary. Make a C with your hand and repeat after me. Say complementary angles add up to 90 degrees. Say it again. Complementary angles add up to 90 degrees. Not to be confused with supplementary angles. Supplementary angles add up to 180. So any two angles add up to 180. So for example, if we had FCR and RCP, those would automatically be 180 degrees. But wait, that looks like a linear pair. That's true. All linear pairs are automatically supplementary, but not all supplementary angles are going to be linear pairs. So in this exercise, you're going to sweep A and B and determine if they are either adjacent, a linear pair, supplementary, complementary, vertical, or some sort of combination. I'm going to do these first two with you. Sweep A, sweep B. Look, we got two straight lines, look like a bow tie. That's going to be vertical angles. Sweep A, sweep B, trace, trace. They share a spine, but they don't make a line, so they're not a linear pair. They don't add up to 90, and they're not adding up to 180. So these are just plain old adjacent and nothing else. Ready? Pause the video, do these four, turn the video back on, and check it out. Welcome back. Let's see how you did. So if we sweep A and we sweep B, you see they're back to back, so we know they're adjacent. But they also add up to 180, so we know they're supplementary. And they share a spine, make a line, we know that they're a linear pair. Sweep A, sweep B. Looky there, they add up to 90, so we know they're complementary. And they're back to back, so they're adjacent. Sweep A, sweep B. You should have seen that they are, yes, they're adjacent. They add up to 180, so they're supplementary. And they are a linear pair. Last one, A and B, made up of two straight lines. They're vertical angles. Looks like a bow tie. Your last activity, I'd like you to go through this diagram here and see if you can't trace and sweep and find a set of adjacent and complementary angles, a linear pair, a set of vertical angles, and a set of non-complementary but adjacent angles. Pause the video, do this on your own. Okay, adjacent and complementary, which means they had to be back to back and make a right angle. So that, an example of that in orange would be these guys right here. There's a right angle. There's several examples, but that would be one. That would be another. So there's two angles right there. One there, there. Back to back, they make 90 degrees in real life. Linear pair, anything that shares a spine and makes a line. So this would be one of our lines. So here, I would have that angle. There's one. There'd be another. They share a spine, they make a line. Share a spine, make a line. Vertical, think bow tie. Bow tie angles, any angles which are made by two straight intersecting lines. So I could do one of these little guys. See that right there? Like a little bow tie. One on either side. You can't see that very well. Let's try another one. This right here. Nope, that's not a straight line. This is. You ready? These two right here. Straight lines, one there, one there. Those would be vertical. Non-complementary but adjacent. Non-complementary but adjacent. That means they're back to back, but they don't add up to 90. An example of this would be this angle here and this angle here. It's not showing up with the green, so I will do it with Sharpie. Right there and right there.